So in the last class, we are discussing about the data flow operators. Data flow operators. So in that we are discussing about them. So what are the different types of delays that you can expect in the data flow modeling? So first thing is continuous assignment delay, that is regular assignment delay. So implicit continuous assignment delay as well as the implicit net declaration delay. So along with the assign statement, so you can add the delay so that you can model the digital circuits in the data flow modeling. So if you want to provide additional delay, so you can give in that form. So for data flow modeling. After that, so we have seen the what are the general format for assign operator. So it will be in the form of expression type as I told. So it will be operators as well as operands are required. So based upon the operands and operators being used, so we can able to evaluate the expression. So based upon the sum expression or carry expression, that is for a full letter, so output can be written in terms of input. So these are some of the examples. So the operators, so operands can be any data type. So it can be of integer type, real time, or it can be floating. There is an integer register type, or it can be real. So many data types which we have studied. So it can be any one of this type. So you can see here some of the examples which we have given, taken as an example for the operands. So once the operand is done, so the any one of the data types, so you can see what are the different operators that are specified for the arithmetic for the data flow operation. So first one is arithmetic operator. So we can see the operator symbol as well as the operands which are required and how many operands are required. So here in the first column you can see the operator arithmetic in the symbol for the arithmetic operator and operation performed. So what are the operation performed and how many operands are required. So based upon that we have seen. So in the last class also we have discussed about this operators. Arithmetic means it can be addition, subtraction, multiplication, division, modulus. All these comes under the operator, and same thing you can see the symbol. And it requires two operands. And the second one is a logical operator. The name logical operator itself, it will be telling that if you perform any logical operation, suppose if any conditions needs to be satisfied, then you are going to evaluate the condition. If it is logically true, then it is going to enter into certain expression to execute. If the condition is false, it is going to execute certain things. Like in if and else condition, so you can see if certain condition is true, that is the logical condition. So that logical condition will be putting into the looping condition. So if the logical condition will be having only two output, one is true or false. The same thing here. These are nothing but the logical operators. Double ampersand is nothing but logical and logical not, logical or. So these are the three logical operation, and correspondingly, so you can have, if it is a negation operation, so it will be requiring only one operand, and if it is a logical and as well as logical or, so you can see that there are two operands is required. So a double equal to b or a double ampersand b. So like that, if you are having any certain conditions to be checked, so you are going to put into the logical operator. And relational operator. So whenever you need to compare between the one operand with another operand, you are going to compare. That is for that you require a relation between the two operands. So you are going to use the relation operator. So relation means, so it can be greater than, less than, or greater than equal, or less than equal. So these are the four different conditions. So that is for a relational operator that is going to have between the two operands. So for all these things, relation operator, so you require minimum two operands is required. So next one is equality operator. So when we want to check the equality condition, suppose if it is a n number of bits are there. So if I want to check n number of bits with whether it is being matched with the same thing. So if it is not So equality operator you are going to check. So if I want to check the equality between the two conditions A and B operand, so we are going to use this. So whether it is equal or not equal, case equal, case not equal. So that is different. So case is nothing but if you, all the operands in operand, four different logic values will be there, 0, 1, x, z, all should match. If it is there, then only it will be true. If it is not matching, any one of the condition is not matching, 0, 1, x, z in all the bit position, if it is not matching, then it will be case unequal. So this is about the operator and the bitwise operator. So bitwise, when you want to perform, suppose if I want to check the parity and all, so we need to perform the bitwise operator, ANDing operation or ORing operation. So if it is there, so we are going to have this type of operator. So negation operator, AND operator, or XOR, XNOR. So these are all bitwise operator. Hence it is a bitwise operator. You require two operands for all the bitwise operation, and the negation operation is required only for one. Next one is reduction. The same operator symbol is there, but the type of operand which you are going to operate is only one. So whenever you are going to have only one operand, then the same operators will be working as a reduction operator. So reduction means what? So reduction means n number of bits if it is there, it is going to reduce to only one single bit. So that is what the reduction operator. Reduction AND. So it is going to perform AND operate AND with all the bits, and it is going to reduce it to 1. So like that it is going to happen. So it will be it will be going to perform for all the bits, and the output of the result will be logic high or logic low. So that is what the operation is going to perform for reduction. Shift operation. So whenever I want to shift the bits position, so we are going to use the shift operator. So after my right shift, left shift is there. So after that you can see there is a arithmetic right shift and arithmetic left shift. So whatever the shifted positions are there, so it will be appended with zeros in the normal logic shift and logic normal right shift and left shift. So that is nothing but a logical shift right and logical shift left. And if you are going to use the operator, so here you can see the symbol arrow indicates the direction through which it is going to have. So if it is towards the right direction, it is right shift. Towards the left arrow, if it is there, then it is nothing but the arithmetic left shift. So it is to compare, to differentiate between these two. So we are going to use another relational operators, greater symbol or lesser symbol, so that to see with whether it is a normal shift right or shift left, or arithmetic shift right or shift left. And next one is concatenation operator. So whenever we need to concatenate, so concatenate means joining the two operands. So if it is required, then you are going to use this operator. So concatenation operator. So replication is same as that of the concatenation. So we are going to use suppose double flower brackets will be used, so that within that any number you can give, so that you can illustrate the replication operator. And last one is the conditional operator, that is requires the three operands. So for all these operators we require the two operands or one operand. So for this it will be having the three operands only this one. So it is the ternary operator. So using these the symbol, so you can illustrate with the example. So normally this will be asked for 10 marks in exam. So how many operators are there, and you have to explain along with the example. So how much the value should give A and B, and arithmetic shift right, logical shift right. So what is the output you have to see. So there are two types of operators in the arithmetic operator. So it requires two operand. So addition, subtraction, multiplication, division, exponent, as well as the these are the operators it is going to have. So here we can see some of the example. A value, B value, D, E, F, everything it has been given. So you can see so how it is going to work with what is the result for that expression. So A into B. So A into B, A is 3 and B is 4. So A into B will be having 12 as the result. So that is what the multiplication operation. So D divided by B. So D is what? So D is equal to 6. E is equal to 4. So when you provide divide operation, so what is the quotient you will be getting? So quotient will be giving D. D is 4 is 6 divided by 4, it is equal to 1. So it is only the fractional part it is not going to consider, because it will be only the real part it is going to consider. So if the value is going to consider as an integer, then you will be having real if you are going to consider, then you will be getting the fractional part as well. So addition, subtraction, as well as this is exponent. So E double star, double asterisk F means E is what? E is 4, F is 2, so 4 square, so it is going to evaluate into 16. So that is what the result. So like this you have to give for each of the operator with example. First you should give the value of the inputs value for A and B, and you have to evaluate this form so that you will be getting the result. So next one is if any one values, here it is x and 0, so x is nothing but I don't care. If it is, suppose if it is there in your operator, so operandly x is also one of the logic value if it is there. So how it is going to perform? Suppose in1 plus in2, so what is the value of that result? So entire result, if it is having x or z, so it is going to evaluate with the value x itself. So it is not going to take the sum. So sum in 1 and in 2 is there. So it is 4 take bit 1010x 1010 it is there. So operand in 1 and operand another operand is in 2. So if it is going to take the sum of these two, then it is going to evaluate to x, because one value if it is having the don't care term, so we cannot expect whether it is 0 or 1. So it cannot provide the accurate result. So it is going to provide the entire result as 4 tick bit x. That means all the bits will be a don't care term itself. The same way here also, so you can see the operation of the modulus symbol. So 13 divided 13 percentage. So percentage is nothing but the modulus symbol. So by 3. So 13 divided by 3. So 3 there is a 3 4s are 12. 1 will be the remainder. So that is the remainder will be getting. So that is what evaluates to 1. So 16 divided by 4. So evaluates to 0. That is what the remainder. So that is what the modulus will be having. That is 1. So here it is a minus symbol. Negative numbers if you are having also it is going to provide. So unary operators. So unary operators. So we have seen the reduction operator is nothing but a unary operator. So I'm sure if the screen will be ಕಾಣಿಸ್ತಾ ಇದೆಯಾ ನಿಮಗೆ? ಅಲ್ಲಿ ಯಾಕೆ ಹಿಂದೆ ಅಂತೀರಾ, ಮುಂದೆ ಬರೋ. Unary operator means only one single operand will be required. So for that single operand, so you can use positive or negative. So that is also can be used as an operator, unary operator. So plus 4 plus minus 5. So before the number if you are going to use, then it is going to indicate whether what type of the number is positive or negative. So next is logical operator, as I mentioned. So logical operation, it will be following the logical expression will be there. So for the logical expression always results in the value of true or false. So that is what the result will be getting. So always it is going to evaluate whether it is a true or false. So there will be, if unknown value, suppose x or z, if it is there in the logic values, then it will be x, will be getting the x as a result, because we cannot able to determine. Suppose 0 1 means we can able to find out whether true or false, but if it is an unknown term is there, that is x is nothing but unknown term, so obviously the logical result will be resulting in the unknown itself. So that is what the logical operator. So this is the example you can consider. So a value is equal to 3, b is equal to 3. So this is the example. So a double or b, so that means double and b. So a and b, so 3 and 0. So that means a is equal to 3 and b is equal to 0. So if you perform logical AND operation, then there is a but 3 is not equal to 0. So 3 is not equal to, that means 3 and 0 if you perform, so it will be obviously result in the 0 as well. So a or b, so it is going to evaluate with 1. So you can see a plus b. So if it is 0 plus 1, 1 plus 1, 0 plus 0, like that only it is going to operate. So if it is AND means it is both must be same. That means a as well as b, both if it is 3, or if it both 0 0 if it is there, then the result will be 1. Otherwise it will be 0. So here if any one of the condition, whether a is equal to 3, b is equal to 0 means both are true condition itself, so it is going to evaluate as true. So it will be evaluated as 1. So negation of a. So negation of a means what? So a is equal to 3. So negation of a means what? So it is going to be false. So it will be 0. So negation of b means evaluates to 1. So that is what the logical operation. So it is going to use. So if unknown terms are there, so it will be, as I told, so it will be, result will be unknown. A and B, so here you can see A is having one unknown term. So whenever you perform logical operation or any arithmetic operation, so if unknown term is there, then the result of the corresponding operation will be result into x unknown itself. So that is what here. So these are the certain conditions, examples which we have already seen in the 8 to 3 binary code priority encoder and all. So we have seen in the with the along with the if condition we have kept. So if I of 7 is double equals to 1, so like that we have checked the condition and we have executed the program. Likewise, you have to, if they ask you, write an example for this logical operation, and if you want to see means, so you have to recall whatever the expression or the example program which you have solved in the HDL lab, and you have to write that one, so that to illustrate the usage of this logical operation. So next one is relation operator. So relation operator means, as I told, the relation between two operands, that is whether it is greater, lesser or equal. So that is what the comparator. The same way here also, 4 and 3 are my inputs. So if unknown term is there, so suppose if unknown term is there, again you are going to have the result will be unknown itself. So x value and y value, z value is being given. A less than equal to b, whether it is 2. So 4 is less than equal to 3. False. So it is going to be logical 0. So here again we will be having either greater means 1. Suppose the result will be 1 or 0. Or if any unknown term is there, so we will be getting x as a result. So the same thing, a greater than b. So 4 is greater than b, it is going to evaluate as 1, logic high. So y greater than equal to x, y is 1 1 0 1 1 0 1 0. This is 10, that is 13. Correct? So binary to equivalent decimal, binary equivalent decimal value is here is 10, is 13. So y value is greater than equal to x. Yes, it is correct. So it is going to evaluate it to 1. And y less than z. So that is what. So we cannot, if z is having the unknown term. So whenever it is having unknown term, so we cannot predict the result. So the evaluates the value, then value is unknown itself. So this is how the relation operator. So equality. So here we are going to have two equal. One is normal equality operator, equal and not equal operator is there. So the second two is the term case equal, case not equal. So in this, what is the difference between these two is, so you can see in the right side. So possible values for a equal to b. So equal to b means what? If a and b both are equal, then what is going to have? So the output will be 1. If a is not equal to b, suppose a and b are two different entities value. So if you are going to have the equality operator, then you can have 0 as the output. Suppose a and b, if you are having any one set, one value, it is of logical x. So x value is 100, so you cannot predict the result, so the output will be x. So that is what you are going to have in these two conditions. But when you come to this case equality, case not equal, that means all the bits should be same. If all the bits is same in all the bit position, then only the output will be result as 1. Suppose a value is 1011, 101x if it is there. B value also if it is 101x, then all the bit position A and B both are same, then you will be getting the result as 1. Suppose 10zx, suppose A is equal to 10zx, B is equal to 10zx, then in all the bit position the value of the logical values is same, then you will be getting 0 1 as the result. If one bit position, if it is mismatching between A and B, then it will be having 0. That means it will be having only two output, that is 1 or 0. That is case equality. So that is what case equal, case not equal. So including x and z. So you can see in the description, including x and z, A must be equal to B. If A is not equal to B, including x and z, then it is results in 0 as the output. So next is what? So the same thing with example I have written here. A is equal to 4, B is equal to 4. See, for any explanation, you have to justify with the example. So theory ಏನು ಬರಿತೀರಾ? So by putting table and all. So after that, if you give example, then only you will get full marks. If you don't write, so register, integer, real, ella kottide. So what are the different data types I have given for you in the internals. Nobody has written example. So register means what? Integer means what? Real. So what are the two different type of notation? Scientific notation, exponential notation. If you give, then only you will get marks. Otherwise, you will not get marks. theory birthday, so nobody will be there to listen to your theory in the description. So answer script theory, nobody will see. If you write example for this subject, then only you will get marks. Otherwise, for any question, if you write program or example, then only you will get marks. Otherwise, you will not get full marks. So A, B, X, Y, Z, M, N. So these are the values has been given. So now A equal to B. So it is double equal to B means is normal equal, not a case equal. So what are the three different outputs? 0, 1 or X you will be getting. So A equal to B. So A is not equal to B, right? So A is 4 and B is 3. So it is not equal. So it is going to evaluate as 0. So similarly, X not equal to Y. X is 10, Y is 11. That is correct. So the condition is correct. So it will be result in true. So output will be 1. So X double equal to Z. So X is what? 10. Z is what? 1 tick, 4 tick bit, 1 double triple X is there. So that means if one unknown term is there, then you will be getting what? So if it is double equal, so you can have the possible output as what? X. Suppose if triple equal was there, then what was the result? 0. So that means only two possibilities you will be having. So that is what? So Z equal to M. Z is 4 tick bit 1 XXZ and M is 4 tick bit 1 XXZ. So both are same in all the bit position. So it is case equal. So the output results in 1. So are true. M not equal to N. So M is what? 4 tick bit 1 XXZ. N is 4 tick bit 1 XXX. So M is not equal to N. So the result is 0. So triple equal means only two output. If double equal is there, then you will be having three outputs you can have 0, 1 or X. So that you should remember and you should write. So this is bitwise operator. So bitwise operator means as I told, so the same XOR, XNOR, AND, OR, NOT and NAND. So all these can be used as a bitwise operator. So bitwise truth table, you know. So bitwise means two operands will be required, A and B. So corresponding truth table OR, NOR, AND, NAND, XOR, XNOR and negation. So this is what the result. So this is the example. X and Y. So bitwise operator means what? So it is going to check the bit position. Suppose if the bit positions are not equal, how it is going to take? So there is also one condition is there, right? Suppose X is of 4 bits, Y is of 6 bits. How it is going to perform? So it is going to take by itself the remaining extended bits will be taken as 0 by itself. So that is what the result. So X and Y it is being given 1011 and 11. So first is negation of X. All the bit positions it is going to perform one bit negation 1010. So where we have used this negation operator? In your lab program where we have used this negation? Huh? Where we have used? No. So when we are taking the 2's complement form, so where there we have used this negation operator. 2's complement ಮಾಡಬೇಕು ಅಂದ್ರೆ first one's complement ಮಾಡಬೇಕು. So one's complement is being done by using this negation operator and by adding plus 1. So it is going to have 2's complement. So a plus 1, a minus 1, auto increment, that example question was there, right? So there we have used this operator. So negation means the result will be 1010 0101. So that is one bit that is a negation operator. So X and Y. So X and Y is going to perform and what is the result? So 1 0. So LSP from 0 to MSP it is going to perform and bitwise and is going to provide the result, corresponding result. So these are all the four different types. Suppose if it is bitwise operator perform bit by bit value and it is going to perform the logical operation. And so suppose if it is okay, suppose if it is A and B are not of same data type, that means data type means all bit positions are not same, then the higher bit position it will be taking it as a 0 by itself and it is going to perform operation. So reduction operation. So reduction operation, the symbol, we are going to use the same symbol. So all these symbols are same as that of the bitwise operator symbol, but whenever we see the reduction, it is going to perform for only one operand. So whenever you are going to perform operation for one operand, then it is considered as a reduction operation. So x is equal to 4 tick bit 1010 is there. Reduction AND. So this is, we are going to call it as reduction AND because only one operand is there. So reduction AND. So all the bit position 1 into 0, 0, 0 into 1, 0, 0, 1 into 0. So that is all the bit position it is going to perform and it is going to result in a 1 bit. So it is equal to 0. So explanation has been done. So 1 and 0 and 1 and 0. So that means it is going to perform bit by bit. Hey Manikanta. Bitwise AND operation, so bitwise OR, bitwise XOR, bitwise XNOR. So this is only one operand. If it is there, then we are going to do this one. So it is about reduction operator, shift operator. So shift, as I told, so normal shift and arithmetic shift, right? The master kya? Para munde. Neenu bara likhi. Nimmindaನೆ ಅರ್ಥ. ಬ್ಯಾಗ್ ಈಗ ತಂದಿದೀಯಾ? ಸ್ಟೂಡೆಂಟ್ ನೀನು? ಎಲ್ಲಿದೆ ಬ್ಯಾಗ್? ಇಲ್ಲಿ PPT ತೋರಿಸ್ತಿದ್ದಿಲ್ಲ, ಫಿಲ್ಮ್ ನೋಡ್ದಂಗ ಬಂದ್ಬಿಟ್ಟು ಜೊತೆಗೆ ಒಂದು ಇದನ್ನು ಇಟ್ಕೊಂಡ್ಬಿಡಿ. ಏನೇನ್ರಿ? ಪಾಪ್ಕಾರ್ನ್ ಬರ್ಕೊಳಕ್ ಕಲ್ತ್ಕೊಂಡ್ರು. ಇದೇನು PPT ಹಿಂಗೆ ಇದೆ. ದಿಸ್ ಇಸ್ ವಾಟ್ ಹ್ಯಾಪ್ನಿಂಗ್. ನಿಮಗೆ ಏನ್ ಬರಿಬೇಕು ಏನ್ ಬರಿಬಾರ್ದು ಅಂತಾನು ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ನಿಮಗೆ ಅಲ್ಲಿ ಐಎಲ್ಲಿ. ಫಸ್ಟ್ ಬೆಂಚಲ್ಲಿ ಕೂತ್ಕೊಂಡಿರೋರು ಬರಿತಾ ಇಲ್ಲ, ಲಾಸ್ಟ್ ಬೆಂಚಲ್ಲಿ ಕೂತ್ಕೊಂಡಿರೋರು ಬರಿತಾ ಇಲ್ಲ. ಇವತ್ತು ಕೇಳಿಸ್ಕೊಂತಿರೋ ಈ ಕಡೆಯಿಂದ ನೆಕ್ಸ್ಟ್ ಅಲ್ಲೇ ಬಿಡ್ತೀರಾ. ಸೊ ಐಯಲ್ಲಿ ಎಷ್ಟೆಷ್ಟು ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಬಂದಿದೆ ಗೊತ್ತಾ? ನೋಡ್ಕೊಂಡಿದ್ದೀರಾ ಮಾರ್ಕ್ಸ್ ನೀವು? ಎಷ್ಟೇ ಬರ್ತಿದ್ದೀರಿ ಸರ್ ನೀವು? ಅದು ಯಾವ ಧೈರ್ಯದ ಮೇಲೆ ಬರ್ತಿದ್ದೀರಿ ಮತ್ತೆ ಕ್ಲಾಸಿಗೆ? ಇನ್ನೇನು ಒಂದು ತಿಂಗಳಿದೆ ಅಷ್ಟೇ. ಅಯ್ಯ ಕೊಡ್ತಾರೆ ಅಂತನಾ? ನಿಮಗೆಲ್ಲ ಸಿ ವಾಟ್ ಹ್ಯಾಪನ್ ನೋ, ಎನಿವೇಸ್ ಲಾಸ್ಟಲ್ಲಿ ಕೊಡ್ತಾರೆ ಅನ್ನೋದು ಒಂದು ಭ್ರಮೆಯಲ್ಲಿದ್ದೀರಾ. ಆ ಭ್ರಮೆಯಲ್ಲೇ ಇದೆ. So right shift y is equal to x, right shift by 1. So whatever the bit position is there, so 1 1 0 0 is there. So if it is shifted towards the right by 1 bit, so you can see x right shift by 1. So whatever the bit it has been shifted, so it is going to be appended by 0. So in the 1 1 0 0 is there, so 1 will be shifted towards right, so this 0 will be shifted right, so 0 will be filled in the vacant position, that is the appended position, so it will be filled with 0. So x left shift by 1, so it will be the shifted portion of the bit will be filled with 0. Suppose if it is a arithmetic right shift, so here you can see what is the result. Arithmetic right shift, so here you can see a is equal to 0, b is equal to minus 10. So minus 10 means what? How you are going to write, how you are going to get the minus 10 value? Minus 10 heng tagondira? 1 0 1 0 you are going to write first, and then you are going to take 2's complement, then you will be getting the negative number of equivalent of 10. So that is minus 10 you will be getting. So that is what you will be getting as this value. So 1 0 1 0 equals 0 1 0 1 plus 1 0 1 1 0. So that is what the result you will be getting as this negative value. So C will be equal to A plus B arithmetic right shift by 3. So arithmetic right shift by 3 means the appended positions will be appended by 1 in the shifted version. So that is what the arithmetic right shift as well as the left shift differential. And next one is concatenation operation. So concatenation means concatenate. So it is nothing but joining the two. So if there is two expressions are there or the two outputs are there, so you are going to use the concatenation operator to join these two. Suppose A is equal to 1 bit value, B is 2 bit value, C is 2 bit 10, D is 3 tick bit 110. So that means these are all having a different various bits positions are there. So whenever I am going to use this concatenation operator, that is with the flower bracket, that is the ribbon concatenation. So B comma C, B the result will be Y is equal to B concatenate with C. So B 00 and C is 10. So the result will be of 4 bits. So you will be having the result Y will be equal to 0010. So that is 4 bits. So that is what the concatenation operation. So same way here you can see A, B, C, D. So any number of bits, any number of data types can be added. Along with the numbers also we can include within the flower bracket if it is there. So it is going to add or concatenate those bits and then it is going to provide the result. So A, B, C, D plus 3 tick bit 001. So 001 at the LSB and remaining A, B, C, D it will be there from MSB to LSB. So this is what the concatenation. So replication is nothing but it is going to have double concatenation you can see. So A value will be having 1 tick bit 1. A is 1 tick bit 1. 4 times of A. So Y is equal to double concatenation 4 multiply with A. So 4 times of A it is going to perform. So A is equal to of what? 1. So the output result will be 1 1 1 1. So that is what the result will be getting. Suppose 4 times of A and 2 times of B. So what is B? B is 2 tick bit 00. 2 times of bit means 2 times you should add B 0000. So 4 times of A means 1 1 1 1. 2 times of B means 0000. So like that we will be getting as a result. And you can see this another example. So 4 times of A, 2 times of B, C. 4 times of A 1111. B means 2 times of B means 0000 and C means it is 10. So you'll be getting as a result. So this is what the replication operator it is going to function. So that means you can any times the operand can be replicated. So that is what the replication operator is going to perform. So how many times you want the replication? So this is 4 times I want the replication means you are going to use the 4 as a number for replication. Condition operator already you are familiar. So conditional means what? Whether it is going to check the condition. If it is true, then true expression will be evaluated. If it is false, then false expression will be having. So that means 3 operands are required. So it is going to work like if and else expression itself. So if else, so if the condition is true, certain expression will be getting, right? Else expression will be getting. So that is the same thing you are going to do with the operator. So that is conditional operator. So using this only I have told you to module to design for 2:1 mux using conditional operator. So write down the mux expression using 2:1 using conditional operator. Design 2:1 mux using conditional operator. ನಾನು ಹೇಳೋದಷ್ಟೇ ಅಲ್ಲ ನೀವೇ ಬರಿಬೇಕು ಲಿಖಿತ್ ಬಂದು ಬರಿತಾನೆ ಈಗ ಬೋರ್ಡ್ ಮೇಲೆ ಬಾ ಬಿಡು ಪೆನ್ ಬಿಡು ಬಾ ಬೋರ್ಡ್ ಮೇಲೆ ಬರಿ ನಾನು ಇದೀನಿ ಹೆಲ್ಪ್ ಮಾಡ್ತೀನಿ ಬರಿ ಗೊತ್ತಿಲ್ಲ ಅದಕ್ಕೆ ಇವತ್ತು ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ ನಿನ್ ಲೈಫಲ್ಲಿ ನೀನು ಮರೆಯಲ್ಲ ಅಲ್ಲಿ ಹೋಗಿ ಬರಿ ನಾನು ಹೇಳ್ತೀನಿ ಅಲ್ಲೇ ಇದೆ ನಮ್ಮ ಚಾಪ್ಟರ್ಸು ಒಂದು ಬಾಕ್ಸ್ ಹಾಕು 2:1 ಯಾವಾಗಲೂ ಅಷ್ಟೇ ಬ್ಲ್ಯಾಕ್ ಬಾಕ್ಸ್ ಹಾಕಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಬೇಕು ಅಂತ ನಿಮ್ಗೆ ಹೇಳಿದೆ 2 ಬಾಕ್ಸ್ ಎಷ್ಟು ಇನ್ಪುಟ್ಟು ದೊಡ್ಡದಾಗೆ ಬರೀ ಅದು ಒತ್ತು ಬರೀ ಬರ್ದೇ ಅಭ್ಯಾಸ ಇಲ್ಲಲ್ಲ ತುಂಬಾ ವರ್ಷಗಳ ಬರ್ತು ಕರೆಕ್ಟ್, ಇವೆರಡು ಬಗ್ಸೆ. ನಿಮಗೆ ಎಷ್ಟು ನಗು ಬರುತ್ತಲ್ಲ, ನಮಗೆ ಎಷ್ಟು ಅಸಹ್ಯ ಅನ್ಸುತ್ತೆ ವ್ಯಾಲ್ಯೂಯೇಷನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ. ಎ ಬಿ ವೈ ಇಲ್ಲ ಸೆಲೆಕ್ಷನ್ ಲೈನ್ ಕೊಡು. ಸೆಲೆಕ್ಷನ್ ಬೇಕಾನೆ. ಮಲ್ಟಿಪ್ಲೆಕ್ಸರ್ ಅಂದ್ರೆ ಏನು? ಮಲ್ಟಿಪ್ಲೆಕ್ಸರ್ ಅಂದ್ರೆ ಕೆಳಗಡೆ ಒಂದು ಲೈನ್ ಹೇಳಿ, ಎಸ್ ಅಂತ ಕೊಡು. ಟ್ರೂತ್ ಟೇಬಲ್ ಬರಿ. ಟ್ರೂತ್ ಟೇಬಲ್ ಬರಿ ಅಂದ್ರೆ ಎಸ್ ಎರಡೇ ಕಾಲಮ್ ಬರಿ. ಎರಡು ಕಾಲಮ್ ಬರಿ. ಎರಡು ಕಾಲಮ್ ಹೆಂಗ್ ಬರೀತಾರೆ ನೋಡೋಣ. ಎರಡು ಕಾಲಮ್ ಟೇಬಲ್ ಅದು. ಎರಡು ಕಾಲಮ್ ಏನು ವರ್ಕ್ಸ್ ಅಂತ ಬರ್ದಿದ್ನಾ?
ಸರ್ ಇಲ್ಲ ಸರ್, ಅದೇ ಸರ್ ಬರ್ದಿದ್ದೆ, ಅವ್ರು ಬರ್ತಾ ಇಲ್ಲ ಸರ್.
ನನ್ನ ಒಬ್ಬಂಗಲ್ಲ, ಅವ್ರು ಅಷ್ಟು ಜನಕ್ಕೆ ಅರ್ಥ ಆಗಿಲ್ಲ. ಅದೇ 2 bucks. ನಾನು ನಿಮಗೆ ಹೇಳ್ತಾ ಇರೋದು ನೀವು ಬರೀರಿ ಅಂತ. ನೀವು ನಂತರ ನಾನು ಬರೆಸ್ತಾ ಇದ್ದೀನಿ, ನೀವು ಬರೀರಿ. ಎಸ್ 0 ಆಯ್ತು ಅಂದ್ರೆ 0 ಕೆಳಗಡೆ y is equal to ಏನು ಬರ್ತದೆ? 0 ಆಯ್ತು ಅಂದ್ರೆ ಏನು ನಾಗಬೇಕು? ಅಂದ್ರೆ ಈ ಸೆಲೆಕ್ಷನ್ ಲೈನ್ 0 ಆಯ್ತು ಅಂದ್ರೆ ಇದು ಸೆಲೆಕ್ಟ್ ಆಗುತ್ತೆ. This is what the mean selection line. Selection means any number of input lines are there. If I want this line to select the output, I want to make it as 0. If it is 1, it can select ಆಗುತ್ತೆ. ಅದು ಈ this is equal to 0 ಅಂದ್ರೆ output y this is equal to 1 ಅಂದ್ರೆ output is equal to ಇದು 0. ಇದನ್ನ ಬರೆಯೋಣ. So once you write, so corresponding expression is ಬರೆಯೋಣ. ನೀವು ಬರ್ಬಿಟ್ಟು ಕೊಟ್ಬಿಟ್ರೆ ಊರವರಿಗೆಲ್ಲ ಅವ್ರು ಬರೀಲಿ ಅಂತ ಹೇಳ್ತಾರಲ್ವಾ? See, it can be done by using normal assign statement, but I have told you to design the marks using ternary operator. Conditional operator and ternary operator both are same. But y is equal to yes not bar a plus yes not into yes not bar ಆಗಿದೆ ಮತ್ತೆ b. ಇನ್ನಂದ್ರೆ ಏನು ಸಾಕು ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಬರ್ಕೊಂಡು ಟೆಸ್ಟ್ ಕ್ಲಾಸ್ ಅಂತ ಏನು ಇದಂದ್ರೆ ಏನಾದ್ರೆ ನೀವು ಬರ್ಕೊಂಡು y is equal to s naught bar a plus s naught b. This is what the expression, but I have told you to design using conditional operator. So very module very what is next? Module and then very module name very ಕೂಡ ತಕೊಳ್ಳೋಣ. ನೀವು ಬರೀತಾ ಇದೆಯಾ ಅಂತ ರೋಲ್ ಪ್ಲೇ ಅಂತ ಕೊಡ್ತಾ ಇದ್ದೀನಿ ಅಂತ. Also, see, any comedy ಆಗುತ್ತೆ ನಮಗೆ ಎಷ್ಟು ಕಾಮಿಡಿ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಯಾಕೆ ಮಾಡಿ ಅಂತ ಬರೀ ಮತ್ತೆ ಬರೀ 2:1 ಅಂತ ಬರೀ ಅದು ಪಕ್ಕ ಐ 2:1 ಅಂತ ಬರೀಯವ 2:1 ಅಂತ ಬರೀಯವ ಬ್ರಾಕೆಟ್ ಹಾಕೋ ಐ ಅದಕ್ಕಲ್ಲ ಇದೇ ತರ ಎಲ್ಲ ಕೊಟ್ಟಿರೋದು ತಪ್ಪೇಳಿ ಎಲ್ಲರೂ ಬರೆಯೋಕೆ ಬ್ರಾಕೆಟ್ ಹಾಕಿದ್ರೆ ಈ ಬರಿಯೋ ಈ ಕಡೆ ಬರಿಯೋ ಬ್ರಾಕೆಟ್ ಓಪನ್ ಮಾಡು ಅಂದ್ರೆ ಇಲ್ಲಿ ಓಪನ್ ಮಾಡ್ಬೇಕು ಬರಿ ಔಟ್ಪುಟ್ ಯಾವುದು ಬರಿ ಏಯ್ ಬರಿ ವೈ ಅಂತ ಬರಿ ಇನ್ಪುಟ್ಸ್ ಏನೇನು ಬರಿ ಅಷ್ಟೇ ಇನ್ಪುಟ್ಸ್ ಇದಾವ ನೋಡು ಅಮ್ಮ ಎಸ್ ಸೆಮಿಕಲನ್ ಹಾಕೋ ಇಲ್ಲ ರೇ ಸಮಾಧಾನ ನಿಮಗೂ ಕರ್ಸ್ಬರ್ಸಿ ನೆಕ್ಸ್ಟ್ ಅವಾಗ ನಾನು ಬರ್ತೀನಿ ಔಟ್ಪುಟ್ ವೈ ಅಂತ ಬರೀ ಸೆಮಿಕಲನ್ ಹಾಕೋ ಇನ್ಪುಟ್ A, B, C. ನೆಕ್ಸ್ಟ್ ಏನ್ ಬರೀಬೇಕು y is equal to y ಬರೀಬೇಕಾ ಅಸೈನ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ಬೇಕಾ ಬೇಡ ಅಸೈನ್ ಅಂತ ಬರೀ ಆ ಕಡೆ ಬರೀಯೋ assign y equals
question mark
a is to b b is to a na ಯಾವ್ದಾದ್ರು ಆಯ್ತಲ್ಲ ಟ್ರೂ ಆರ್ ಫಾಲ್ಸ್ ಯಾವ್ದಾದ್ರು ಆಯ್ತು ಟ್ರೂ ಆದ್ರೆ ಇದು ಫಾಲ್ಸ್ ಆದ್ರೆ ಇದು ಇಲ್ಲಿ ಏನ್ ಮಾಡಿ ಬರೀ ಏನ್ ರೀತಿಯ ಬರುತ್ತೆ ಸಾಕು ಎಂಡಾಗಿ ಬರುತ್ತೆ ಬಿಗಿನೇ ಮಾಡಿಲ್ಲ ಇಷ್ಟೇ ಇಷ್ಟೇ ಸಿಂಪಲ್ ಇರೋದು ಆಯ್ತಾ ಸೊ ನಾವು ರಿಪಲ್ ಕ್ಯಾರಿ ಆಡರ್ ಪ್ರೋಗ್ರಾಮ್ ಗೊತ್ತಲ್ವಾ ಕ್ಯಾರಿ ಲುಕ್ ಅಹೆಡ್ ಆಡರ್ ಬರೀರಿ 4-bit ಕ್ಯಾರಿ ಲುಕ್ ಅಹೆಡ್ ಆಡರ್ ಕ್ಯಾರಿ ಲುಕ್ ಅಹೆಡ್ ಆಡರ್ ಅಲ್ಲಿ ಏನು ಕ್ವಾಂಟಿಟಿ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಹ್ಯಾವ್ digital system design ಓದಿಲ್ವಾ ಫುಲ್ ಅಡ್ರೆಸ್ ಮಾಡಿರ್ತಾರೆ ಅದನ್ನು ರಿಪಲ್ ಕ್ಯಾರಿ ಅಡ್ರೆಸ್ ಮಾಡಿರ್ತಾರೆ ಅದಾದ್ಮೇಲೆ ಕ್ಯಾರಿ ಲುಕ್ ಅಹೆಡ್ ಅಡರ್ ಅಂತ ಮಾಡ್ತಾರೆ ಕ್ಯಾರಿ ಲುಕ್ ಅಹೆಡ್ ಅಡರ್ ಅಲ್ಲಿ ವಾಟ್ ಈಸ್ ದ ಮೇನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ವೈ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಫಾರ್ ಕ್ಯಾರಿ ಲುಕ್ ಅಹೆಡ್ ಅಡರ್ ಅದು ಆಡರ್ ಅಂತಾನೆ that is also going to perform addition only, right? So what it is going to have difference between normal adder and the carry look ahead adder.
Generate carry takes time to measure time.
Correct. So that question, what we are going to modify the adder? Hey, correct, it is correct. Two functions we are going to use. What are those? Next class alli program ಕೊಡ್ತೀನಿ 10 marks question definitely it will come. Data flow modeling alli carry look ahead adder 8 to 10 marks definite ಆಗಿ ಕೇಳೇ ಕೇಳ್ತಾರೆ. Generate function, propagate function ಅಂತ ಕೇಳಿದಿರಾ? That is what additional thing.